Welcome to the latest episode of Reimagining Mobility. I'm here with Andy Roberts, Chief Engineer for Systems at Mobility Technologies at AVL. So Andy, tell us a little bit about systems engineering.
Okay, sure.
It seems like it's a big topic right now. A lot of people are talking about it. Tell us, what does it really mean? What systems engineering really mean? It sounds really good, it sounds very important, but
Sure.
maybe there's many people that don't really know exactly what that means or how AVL looks at it.
Absolutely. So yeah, I think systems engineering really is the approach, the discipline of looking at whatever you're developing overall as a system, not as individual components, not as elements on their own that you develop separately, but more as a integrated full system. And if you deal with it in that way, if you look at it in that way, you end up with a much better product, a more integrated product, a more efficient, I would argue a more robust product, rather than as individual components. So as far as systems engineering at AVL, I think like most of certainly the automotive industry, it's progressed quite a bit over the last maybe 10 years. Originally systems engineering really came from I would say a controls, a software development sort of approach, where it was very much used to define, what the software needed to do. So we'd look at a high level of say like an engine controller and say, okay, what does the engine controller need to do? We'd capture some requirements for that. We'd then break that down into what the hardware needed to do, the software needed to do, the sensors needed to do, and then we'd use that to develop software and the controls hardware as well. Now, I think it's really being adapted across the automotive industry much more broadly. It's still a big part of software development, but it's also really key, I would argue, to hybrid system development and ADAS system development. And that really is driven by the complexity of these systems and the interaction between the components, between, say, the powertrain, the ADAS system, the off-board system as well, the GPS, the connection to the infrastructure.
I just want to ask, so does it include the cloud then as well? When we're talking about AI in the cloud, especially for autonomous driving, when we're talking about telematics for route calculation, where's my next gas station, where's my next charging station, is it open, is it working? So does it include the cloud as well, not just on the vehicle?
Yeah, so from, I think at the inclusion of the cloud, absolutely. So if we took an example of a system where we need to understand the range of the vehicle. So you could do that pretty simplistically. You could say, well, I'm traveling from point A to point B through my GPS I put in my route. It's 300 miles. What's the range? What's the state of charge of my battery, and therefore what's the range? But in reality, you want to be able to bring in the GPS information. You need to be able to bring in the traffic information, the gradient of the road. You also, so that's that piece that needs to come in from the off-board, the GPS and all of that related information. But you also need to understand from a powertrain perspective, what's the state of charge of the battery, but also what's the state of health of the battery. You probably also want to understand how the driver historically has been using the vehicle, driving the vehicle, because that will obviously affect, on that 200 mile, 300 mile.
Subjectivity of it.
Yeah, so he may be, or she may be getting less mileage out of their battery because they're being more aggressive in the way they drive. So really now, OEMs, vehicle system developers are really starting to bring all that information in together. So the off-board, the powertrain information, the battery information, how the driver's driving the vehicle, and you need to bring all that together in a systems approach. So you need to understand from a higher level what's the requirement. Well, we need to understand what the range of the vehicle is over a defined route. How do we do that then? Well, we need to bring in GPS information. We need to bring in powertrain information, battery information. Bring all that together into an accurate calculation that can then be used to predict what the range of the vehicle is.
So for many years now, I've been leading teams that always talk about model-based systems engineering. And for many years, I felt like every time I asked for details, I felt like, okay, yeah, I get it, but are we really using models? You know what I'm saying? I felt like it's almost a little bit like big data. Everybody talks about big data. Everybody collects big data. Everybody does a little bit with big data, but I struggle at times to really see what we're doing with truly big data, mining it, right? Going to the data lake, mining it, using it.
Yeah.
Tell me a little bit about model-based systems engineering, where we are now as maybe opposed to, let's say, 5 years ago.
Yeah, absolutely. So I think model-based, as you say, model-based system engineering has been talked about a lot. 5 years, maybe even more than that. And I think there's been some usage of it, certainly my experience, in that more of a limited fashion. But in recent years, maybe the last year or so really, I've seen a big increase in the use of that.
Okay.
And the use really of, a graphical way, I would argue, to represent requirements. And unlike Visio, the tools we use for like model-based engineering, you could use Visio to draw up architecture diagrams, interface diagrams. But the real key thing with model-based systems engineering tools, approaches, is that all these different diagrams are linked together. So you change one, it changes in the other diagram.
Automated.
In an automated
Sure.
fashion.
Yeah.
Obviously, then also link that to your textual requirements as well. From a controls perspective, it's even getting to the point where you can start at the top level of your set of requirements, maybe textual, link that into your model-based approach tool, cascade that down to your different, I would say, architecture and interface views, and even down to the level where you can define a controls architecture within a model-based systems engineering tool, and actually then take that architecture and then deploy that, or I guess export it, and then start actually developing, say, in Simulink, in that architecture you defined from the systems perspective.
Okay.
So it's certainly becoming, I would say, in most projects now, actually, we are starting to pretty actively and aggressively use.
I just want to ask, so if you had to guess, what's the percentage of projects we're doing for customers or with our partners that use model-based versus just let's call it the standard systems engineering approach? Is it 80% use model-based? Is it 60%? Or
I would sort of possibly say 50% or so, but
Okay.
it seems to be more. I think the ADAS kind of projects are certainly adopting, I should say so.
Yeah.
That more quickly, I would say.
quickly,
Although in the powertrain domain as well, it is certainly becoming adopted as well and
Okay.
used, and it's pretty powerful. It's a very good way, I think, for people to quickly understand what the system is and the interactions. Much quicker, obviously, to understand a diagram, a graphic, an image than words. So, yeah.
So at AVL, we see ourselves as pretty strong at model-based or systems engineering. Let's just keep it generic, systems engineering. What do you believe makes us good at that, or makes us so good at that, or makes us unique? Is it our background in lots of different domains in the mobility space? Is it the domain knowledge of individuals that then brought together bring it, or is it the flexibility and the wide breadth and depth of knowledge that our people bring that allows them to do that?
I would say, to be honest, it's all of those things. Certainly the expertise and the deep knowledge in the different disciplines is a key part. But the other thing is, over the last, certainly 10 years or so, there's been a very active progression of defining our systems engineering approach. How do we do systems engineering? So across AVL globally, I've been involved in it. A number of the team in the US have worked with the teams in Europe and China and everywhere else in the world to develop and agree a way that we do systems engineering.
So a common way across all of AVL.
Absolutely. So, that has to be it has to be certainly adaptable as well. So it has to be scalable to the different projects we've got. Every project generally is different, so we have to have an approach, a way that can be scaled to be used on all these different types of projects, whether it's an ADAS project, a conventional powertrain, a hybrid powertrain project. We have to have an approach that is common and understood globally by the systems engineering team and the teams working with us as well. So also it allows that we can work globally together as well, because if we're working in the same way and we understand the same way of working, then the US can work with Europe, with China, everywhere else in the world as well.
What makes a great systems engineer as an individual? Is it the experience? Is it the ability to think low level but also higher level from a complete system? What this thing is that I have to design? Yeah. Is it the mentorship programs that we have where you and others mentor people? Is it they need to rotate around first to lots of different groups to be able to understand the different components? What makes a great systems engineer?
I mean, I would argue that what makes a great systems engineer, a big part of that is an interest in the overall system.
In the overall system, okay.
I mean, some people really like to get into the real details of one specific system. That's great, and we absolutely need those people. And we have a lot of hugely talented, real technical experts in certain areas. I think systems engineers, most of the systems engineers that I work with, like the overall understanding everything really. They like to see the big picture, but then they be able to take that and sort of dig down into, well, what makes that big picture? How a hybrid powertrain, you've got to understand internal combustion, you've got to understand electric drives, inverters, DC-DCs, maybe if it's a plug-in, you've got to understand onboard chargers. I think having people that are real, have really got an interest and a passion to understand that, that's really makes a really good systems engineer. But then also to be able to work in a methodical way, to be able to go from a high level, maybe vehicle level description of what's needed and be able to methodically break that down and to say, well, okay, from a vehicle perspective, we need this. What does that mean from the powertrain, from the chassis? I think that's really quite key.
When you take the different systems engineering projects, let's say you have done, give me an example of an extremely complex one and an example of maybe not an easy one, but a more, let's say, easier to apply systems engineering approach to it.
Yeah, sure. I mean, I think the ADAS projects we're now working on, there's a lot of complexity there because you have got to, obviously there's lots of ADAS features. So whether it's AEB, FCW, ACC, all these features we have to understand what they each need to do, but then they all have to work together in conjunction. But they also have to then work, obviously, with the powertrain as well. There's elements of off-board information we're bringing in. There's the perception system, so we need to be able to clearly define what is needed from the perception system. So those are pretty complex projects. And hugely interesting for that reason. I think the more simple, straightforward, I mean, transmission projects we've used, I wouldn't say they're super simple, but it's a component, a system that we're integrating into maybe an existing vehicle platform. So then you're really focusing on what are the cascaded requirements from a vehicle perspective, performance-wise, for the transmission, ensuring that the transmission delivers that and interfaces correctly with the other vehicle systems.
Sure. Where do you see, let's say, just again, systems engineering, not necessarily model-based, but I think we all know that's where it's going to or continues to push towards. But where do you see systems engineering in 3 to 5 years? Do you see changes? Do you just see more of a deployment of it across even more fields and areas in the mobility space, or do you see it become even more, let's say, digitized with much more digital features, digital twins coming in, AI coming in? I don't know. What do you see it in 3 and 5 or to 5 years?
Yeah, I mean, I think the tools that are being used, some of the existing tools are not maybe the easiest to get in and use. I think there's a lot of the tool developers are working to make them more user-friendly, I would say, and easy to get into, and add additional features and functionality and sort of ability to connect those model-based tools with existing requirements tools, simulation tools as well. So I think there's certainly an improvement in the tools themselves, and therefore the adoption of the tools. I mean, I kind of always think, back from a software perspective, many years ago we started, writing in assembler, and then we kind of moved up kind of see, and then from that we move to sort of Simulink, so more graphical kind of.
Yeah.
And there is certainly, I say from a controls perspective, I think more of a move to be able to even be starting to really define your software requirements within the model-based environment, and actually be able to have tools that will sort of automatically or semi-automatically bring that down into actually being able to develop code and implement code. So I think that's potentially an interesting area.
Okay. How do you see systems engineering as it relates to, let's say, platooning on heavy-duty trucks? Do we see it as there needs to both trucks or all trucks, even with cars, let's say, that come in as well, maybe part of the platoon? Do they all have their own systems engineering, and then the overall is a systems of systems? Or how is that to be looked at?
Yeah, I think that's a really important question. I think we have to be developing standards so that we all, effectively the vehicle needs to provide data back up into the cloud that can then be used in some way through some intermediate, I guess, by the other vehicles as well. I think standards and need to be adopted by people to be able to implement that. I mean, it's
Okay. If you think about the challenges we have in the mobility space, passenger vehicles, let's stick for a moment, but I think even off-road, military, or heavy-duty trucks, there's more and more technology, let's say, crammed into the vehicle, the mobility device. How important is systems engineering in this quest to make these pieces, at the end of the day, work to the benefit of the user, right? The driver, the passenger. Yeah. Otherwise, you have a conglomerate of different technologies, but they don't really gel together and really work together, and the user experience may be disappointing. So how important is systems engineering versus maybe, let's say, user experience engineering?
I think it's absolutely key. I think, again, the aim of systems engineering really is to develop a system that's almost, greater than the sum of all its parts. Those parts on their own, unless there's coordination and a cascading of requirements and interfaces down to all those subsystems and components, you just end up with a bunch of components that kind of do what they're supposed to do, but not in an efficient and sort of most optimal way.
Yeah, cohesive way. And
but as far as the user experience, I mean, that's a key input as well to that systems approach.
Okay.
I think we have to, and when we do on the ADAS side, one of the key things we're looking at, or an input into ADAS system development is, if we're developing a system, is what is the user experience? That's baked in from the very beginning. How is this going to be used? What are the use cases for this feature? What will this feature experience as far as what the user wants from it and the environment it's going to be in as well? And that really needs to be very much understood as we develop these features and systems.
Okay.
So it's always the end user, really the customer, that has to be kept in mind, and that's who in the end we're delivering to.
So everybody talks about the software-defined vehicle, right? Obviously, systems engineering is a key piece to allow this to happen. But let's say for a moment there's issues in the field and we can use over-the-air updates to address the software. Let's assume we can fix it with software, address it with software. How critical is the systems engineering approach that needs to be happening before that to really allow to do this? And how do you guys look at this? Okay, this could be a potential in the future. How do we address this, right? Because it's not necessarily this is how ultimately the whole system, the vehicle, heavy-duty truck, off-road equipment, passenger vehicles, is functioning or has to function. But how do you, in your approach with systems engineering, try and foresee what you need to do in the future in case there's issues that you can address with a software over-the-air update versus recalling vehicles or having everybody go back to the dealership?
Absolutely. I mean, I think that certainly is that's a requirement that has to get fed in from the very beginning, from the top. this vehicle, this system, depends what level we're working at, needs to have the ability to support over-the-air updates. Now, that also means that you critically need to be bringing in and considering the cyber security aspects as well, because obviously that's key if we're starting to remotely update software. So all those things have to be considered and have to be a key part of the requirements that we're defining at the beginning of, say, a vehicle program or a subsystem program. And then it's really making sure that those requirements for cybersecurity, for over-the-air updates, functional safety, are correctly cascaded down then to the components, the systems that need to then deliver that functionality. And if it's across multiple components, they obviously need to do that in a very synchronized and aligned way. So.
Okay. Thank you, Andy. Any last thoughts from your end, from systems engineering, that we maybe didn't catch here that's important in your mind?
I mean, I guess sort of summing up, I think, systems engineering has been a key discipline, I would say, for certainly for software and controls for many years. Now, as we move towards more and more complex and connected systems, ADAS, electric vehicle, electric powertrains, hybrid powertrains, you cannot develop an efficient, robust system without a systems engineering approach.
Okay. All right. Thanks, Andy. Very insightful. Appreciated. Thanks, everyone, for tuning in. Until next time.
Thanks for listening to Reimagine Mobility Podcast. If you like this episode, please subscribe and tell a friend.